Okay, let's look at number 4, cross-sectional volume. Find the volume of the solid whose base is bounded by y equals 4x, 4/3 x minus 3. So this equation, y equals 0 and x equals 0. Okay, so now, as I told you, this is the floor plan. It's kind of like graphing these, but as if you're looking down onto the floor. I'm going to try to, excuse me, I'll draw this two-dimensionally first, excuse me, and then try to draw a three-dimensional replica of this. So 1, 2, 3, and your slope is 4. So 1, 2, 3, 4 over 1, 2, 3. So this is the y equals 4/3 x minus 3. Y equals 0 will be your vertical axis. Okay, so I'll just kind of overlay it like here. And x equals 0, I'm sorry, y equals 0 is your horizontal axis. X equals 0 is your vertical axis. So when you have all of that, and you look for the enclosure, it's this little piece right over here. And we're looking for the volume, not of this flat figure, but when you overlay or when you put on top of it semicircles. It says here cross sections perpendicular to the y-axis that are semicircles. If I draw this three-dimensionally, I'm going to put x and y on the ground. So this right here will be my y. This right here will be my x. And let's see, 1, 2, 3. So 1, 2, 3, 4, 1, 2, 3. So the yellow line, or let's see, I'll try to stay consistent. Oops. So the straight line will be from here to here, like this. Okay. And we're going to bound it with x equals 0 and y equals 0. So this shade right here is this. Now what you want to do is draw semicircles perpendicular to your y-axis. And what that's going to look like is it's going to look something like this. Okay, I don't know if that, yeah, I think you can see that. Okay, let me draw another one over here. So draw it like this. And then, let's see, this one. This, and maybe like that. Okay. All right, so basically, this is on the ground. These semicircles are sticking up like tacos, and you're going to line up infinite amount of them thinly sliced, and you want to find the volume of that cross-sectional figure. All right, now before we start, remember, we have to figure out the volume of a cross-section of a of this little taco over here. It's actually a flat cylinder, and what I want you to see is this. Take that yellow taco right there, put it on the ground, and let me draw the full picture, meaning before it's cut in half, this is what it looks like. And when you cut this right here, like this, and you split it apart, you're going to see something like this. Okay. That one kind of looks funny, but so you're taking this and putting it up like right side up onto this little quadrant or this triangular area. And depending on where you are, it's going to get bigger and bigger and bigger, and you're going to be adding up all of those volumes. So we're ultimately looking for the volume of this prism divided by 2. Now, as I told you, a prism is any three-dimensional figure that has two bases that are congruent and they're parallel, and they're separated by a height. So this right here technically is your height. But if you stand it up like this, the height will be right over here. Okay? So even though it's like laying down on the side, we need to think of it as this figure. This is your height, and the volume of any prism is very simple. It's capital B times H. Area of the base, the capital letter B represents the area of the base. The area of the base is basically a flat circle. Okay? In this case, it's pi r squared. And height is represented by this. Now in this picture, you'll notice that the height, if you touch the y-axis, they're little tiny spacings of y values. Like if you look at it from here and you draw your cross section, just the base touching the two sides here, this little spacing right here will be your height of the prism, and you're going up the y ladders. This will be called dy. And so we're basically going to fill out this equation. Volume equals pi r squared as the area of the circle times height, which is dy. And dy is very important because this is going to determine what the ultimate volume equation is going to look like. Everything in this part right here has to be turned into the letter y, or write it in terms of the y letter. Now, obviously, it's not a full circle, so what do you have to do to this equation? You have to divide this by what? Divide it by 2 to get this. Okay? All right, so now the next question is this. What's the radius? Now, the radius will be half the diameter from here to what? Here to there. But we have to look at the actual picture to figure out how to determine, or what equation is going to help us determine this diameter right over here. You see this? That's your diameter. And so if you cut the diameter in half, it will be whatever the diameter is divided by 2. Now this distance right here is determined by the x coordinate on this line. So if you go over here, the diameter, and I'll just draw this, I'll use green. Okay, this is your diameter right here. It's basically an x value, an x value that's represented by this line. Because if you go up, it gets wider. It's basically another x coordinate on this line, y equals 4/3 x minus 3. But we don't want the whole diameter. We want the radius. So radius will be x divided by 2. So what we're going to do is set this equal to the letter x, which will be represented right here, and then divided by 2, and all of that will represent our radius. So, excuse me. So let's go and solve for the letter x right now. So we'll add 3 to both sides. This will be 4/3 x, and then multiply both sides by 3/4. So this will be 3/4 y, and multiply 3/4 to 3. That'll be 9/4. Okay, so here is my diameter, as it were. Okay, represented by the letter x. But we don't want a diameter, we want a radius. So radius would be simply x divided by 2. And if you multiply 1/2 to all of this, this will become 3/8 y plus 9/8. Okay, so this is my radius. Okay, excuse me. So let me just recopy that down here. Radius is equal to 3/8 y plus 9/8. And I'm going to take this and plug it in right over here, and then take the whole equation and divide it by 2. So this is the hardest part to these equations. We're not even doing the integral yet. It's setting up an integral that we can use to find the volume of this cross-sectional figure placed on the base that's bounded by a line and the x and y axis. Okay, so volume is equal to pi, and the radius is squared, so I'll put it in there. So this would be 3/8 y plus 9/8. Okay, and all of that divided by 2. All right, so we're pretty much done. Well, there's a couple more things we have to do, but notice dy is here, and the equation is set in terms of y. Okay, so now we have to figure out how to find the lower bound and the upper bound for this integral. I'm going to pull out the pi over 2 outside because they're just constants. We don't need to worry about, using them in part of the equation. 3/8 y plus 9/8 is the main equation, and dy, and the question is from where to where? Well, this one's easy because we're going up the y-axis, and this region right here starts at -3 because that's your y-intercept of this line, and you just go all the way up until you hit 0. Okay, now don't look at this. This is your x-intercept. We don't need that. We just need it from, we're cutting the semicircles this way all the way up to y equals 0. So we'll put here negative 3 to 0, and we'll punch, oh, I'm sorry, this will be squared. I totally forgot about that. And this will give us the equation, I mean the volume of all of those half semicircle prisms from negative 3 all the way up to 0. Okay, I'm trying to figure out, should I multiply this out and do it? Now you can plug this into your calculator. I don't have, do I have it? Let me see if I have an integral calculator on my iPad. That's not it. Okay, I'm gonna work it out by hand, but this problem says use a calculator, so you can actually use a calculator to solve this. Wait a minute, I thought I had it here. Let's try this one. Differentiate. No, okay, I'll just do it by hand. No. Okay, I'm gonna just use my calculator. I'm gonna use this one. Okay, so I'll just type it in. The answer is, let's see, where's your answer? Where's my answer? It's 81 pi over 128. Okay, and so what we're gonna do is get the decimal approximation of this actual answer and see if this yields the decimal approximation using our calculator. So what's 81 pi over 128? 81 pi over 128 is 1.988. Okay, so our goal is to get that. All right, so let's type this in. And so I hit math or menu, go to option 4 for calculus, numerical integral, fill in my lower bound and my upper bound, use a parenthesis and write 3x divided by 8 plus 9 over 8. And then I need to raise that to the second power and square it and put x here. Okay, so on paper we have everything in terms of y, but when you plug it into your calculator, you could just use x. Okay, and then I hit enter, and before I multiply, I didn't put this in, so it'll be pi over 2. What I got was 1.2656, and if I multiply this answer by pi over 2, where's my pi? There it is. Divided by 2. Guess what? Oh yeah, 1.988. All right, so there it is. Okay, so the setup is quite long, but once you find your antiderivative setup, this right over here, if it's a calculator problem, just punch it in and you will have your answer. Okay, I think there might be only maybe one problem where you have to work everything out. The rest should be a calculator problem. The difficulty is writing up all of these things, but it's very simple because you're only looking for this right over here, but in an abstract manner. Okay, so all of these will be prisms. This is your main equation, b times h. I would always figure out what h is, dy or dx, based on which axis it's perpendicular to, and then just fill out the volume equation. The area of the base equation, and just plug everything in.